find the current Ix by making use of mesh analysis. So here, as I already told you, here you can see that there is one current source, right? Okay. So there is a practical current source here. So before going for application of mesh analysis, this current source, you convert that into a voltage source. Okay. So you have a current source 8 amps with 10 ohm resistor in parallel, that we convert it into a voltage source. Okay, what about the polarity? You look into the direction of this current source here. This end will be plus, this end will be minus. So what is the value of current source? It is 8 into 10, 80 volt in series with 10 ohm. 10 ohm you can write it here or you can write it after this 80 volt voltage source. Okay. So first step is you convert this current source into a voltage source. Okay, you can keep as it is, but if you keep as it is, then what you have to assume one current here, I1, I2 here, I3 here. Then one more current you need to consider this as I4 so that you will get 4 equation. Okay, so where I4 is nothing but what? If I consider I1 here, I2 here, I3 here, and I4 here, I4 is what? See, in this loop, you have only the current source, isn't it? You have current source at the perimeter of the circuit. So, I4 is nothing but minus 8 amps. Why it is minus? I am assuming the current direction in the clockwise direction, but the current source, you can see, that is 8 amp current source is going in the opposite direction as that of the orientation which I have assumed. Right? So I4 is minus 8 amps. So you can keep as it is so that you will get I1, I2, I3 and I4 is minus 8 amps. Here we need to substitute. Okay. Or else what we can do is that, okay, instead of considering 4 variables, you can convert this current source into voltage source so that you will get a circuit like this. This is 8 ohm, this is 2 ohm, this is 100 volt voltage source. Here you have 4 ohm. Okay, this is 3 ohm. Here you have 10 ohm. This is plus to minus here 80 volt. Okay, then 5 ohm. Okay. Now this is the circuit. You write the equation for mesh 1, mesh 2 and mesh 3. Write down the equation and determine the values of I1, I2, I3. See, you can keep as it is, but here you need to assume a one more current, that is I4. Since the assumed direction is opposite to the direction of the current flow here, you have to consider I4 as minus 8. Then you write the equation for mesh 1, 2, 3 and simplify. Or else you have to convert this current source into a voltage source, that is the practical current source into a practical voltage source, so that you will get three meshes. Write the mesh equation for the three meshes and find out I1, I2, I3. Write down the equation and tell me what are the values of I1, I2, I3. See, what is the first equation? it is 100 minus, I am writing for this circuit, it is minus 8I1 minus 4 into I1 minus I2 equal to 0. Okay, that is the first equation. Second equation is minus 4 into I2 minus I1 minus 2I2 minus 3 into I2 minus I3 equal to 0. That is the second equation. Okay, then minus 3 into I3 minus I2 minus 10 into I3, okay, plus to minus minus 80 minus 5 into I3 equal to 0. This is the third equation. What are the values of I1, I2, I3? What are the values of I1, I2, I3? So first equation, when you simplify it, what we will get here? It is 12I1 minus 4I2 equal to 100, right? Equal to 100. The second equation is minus 4I1 plus 9I2 minus 3I3 equal to 0. Next one is minus 3I2 5, 10, 15, 18 minus 18I3. This is plus 18I3, or this you can write it as plus, this you can write it as minus. Okay, equal to 0. Okay, plus 3I2 minus 18I3 equal to minus 8 equal to equal to 8. Right, equal to 8. Or you can write minus 3I2 plus 18I3 equal to minus 8. These are the three equations. Simplify that. Find out what are the values of I1, I2, I3. Okay, what about Ix value? What are the values did you get? See, wherever that coefficient is not there, for that you need to enter it as 0. Okay. See, the first equation I3 coefficient is not there. Okay. That is 4I2 plus 0 into I3. Similarly, in the third equation, I1 coefficient is not there. Are you getting it as I1 equal to 9.26, I2 equal to 2.79,
minus 3.97,
and I3 equal to minus 3.97. Are you getting these values? See, in the problem, what they have asked you to find out what is Ix. So what is Ix? Ix is nothing but I2, that is nothing but 2.79 amps. Did you get these values? Yeah, okay. We'll take on the next problem. Find the current through 24 ohm using mesh analysis. Find the current through 24 ohm using mesh analysis.
Ma'am, in previous problem, how to get that Ix?
Ix is the current they have given here. Current through this 2 ohm, right?
Okay, yeah.
Okay. This is the branch current here. This is the
So
mesh current I2. So what is the current Ix? Ix is nothing but I2
2.9.
itself. Huh?
2.79.
Okay. Yeah, 2.79 amps.
Because I2 is equal to
Suppose
2.7.
Yeah, 2.7. Suppose if it is through this CD, okay, then it should be, suppose if they have given Ix here or say Iy here, what is Iy? Iy is I1 minus I2.
Yes.
Got it?
Okay.
Suppose this is Iz, then it is I2
I2
minus
minus I3.
I2. Hmm?
Yes.
Okay, take the next problem.
I'm here 10 ampere. We should multiply for both 10 ohm resistor. Man.
No, 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 no. That is delta connected, right? So it is
Yes, ma'am.
not in parallel. Sorry, this is star one, right? Okay. So what you should do is that the voltage source, you need to convert that into a current source so that two current sources will come in parallel, right? Add the current source value, the resultant current source, you convert that into voltage source. Then apply KVL.
Yes, ma'am.
See here, first you convert this voltage source because we have a parallel current source here. Convert this voltage source into a current source first. Then add up the current source value. Then convert that into voltage source. Then apply KVL.
Ma'am, after converting the voltage source into current source, the direction will be upward, right?
Yeah, the direction will be upward. See, first what you do is here, this one. This is positive, positive terminal is here, right? So the current is, so this is 100 by 10, okay? That is 10 amp current source, and you will get 10 ohm in parallel. Then here you have 10 amp current source. Okay. Now 10 and 10. This becomes 20 amps. Okay. 20 amp. Parallel with that, you will have 10. Okay. That you convert that into voltage source. That is 200 volt in series with 10. So the circuit after conversion, what you will get is that 10 ohm. This is 200 volt. This will be 10 ohm. This is 10 ohm. This is I1, I2. Is any doubts here? Now we apply KVL to each mesh. Okay. That is the first equation is 200 minus 10 I1. Yeah, this is one. Only one. Okay, this is not there. Okay. So this one 20. Only one 10. Okay, this is not there. 200 minus 10 I1 minus 10 into I1 minus I2 minus 10 into I1 minus I3 equal to 0. Okay. Next equation is minus 10 into I2 minus I1 minus 10 I2 minus 10 into I2 minus I3 equal to 0. Next equation is minus 10 I3 minus I1 minus 10 I3 minus I2 minus 24 I3 equal to 0. The equations, you simplify it. See here, you need not find all I1, I2, I3. If, only if you find I3 is sufficient. Okay? Because you need to find out what is the current through 24. But when you are solving, you will get all the values. So that you can write all the values I1, I2, I3. So what are the values of I1, I2, I3? Are you getting I1 as 8.97, I2 as 3.97, I3 as 2.94? Did you get these values? So what is asked there? Current through 24 ohm resistor, that is nothing but I3. Current through 24 ohm is asked. What is that current through this particular branch? It is nothing but the mesh current I3, right? So I3 is nothing but 2.94 amps, what we have got. Is any doubts? Okay, since the current through 24 ohm is asked, that is nothing but I3. Okay, you take down the next problem. Find the currents Ix and Iy using mesh analysis. Find the currents Ix and Iy using mesh analysis. And did you get the materials? Are you able to take this module, subject to module? Anyone checked it?
No, ma'am, I can't. That subject is not uploaded till now.
No. Now I have added it. Okay.
No, for
Around
us,
11 o'clock. Huh?
sub-
Yeah?
Yeah, ma'am. Now it's accessible.
Yeah, I have added your section. Then just check it after the class. Okay. So find the currents Ix and Iy using mesh analysis. See here, what you can see is that there are two dependent sources. The one dependent source is 2 into Ix. Okay. What is the type of the dependent source? It is current controlled voltage source, right? Okay. You have one more dependent source here, that is plus 2 Iy. This is also current controlled voltage source. Okay. So first we'll see what is this Ix and Iy. Ix is what? See this, the voltage of this voltage source is controlled by the current Ix. What is current Ix? Suppose if I consider the mesh current in this mesh as I1, this mesh as I2, depending on this I1 and I2, what is Ix? Ix is nothing but I1 minus I2, right? If I consider this current as I1, the current flowing in the second mesh as I2, what is Ix? Ix is nothing but I1 minus I2. So what is the value of this voltage source? It is 2 into I1 minus I2, because Ix is what? It is, they have given. Okay, Ix is the current flowing in this particular branch. Okay, what is the orientation? You can see here, it is in the orientation of I1. So Ix is I1 minus I2. So this voltage source value is nothing but 2 into I1 minus I2. Okay. So what about IY? Can you tell me what is the value of IY? What is IY? What is IY? What is IY? Yeah, IY is nothing but I1. Okay. IY is nothing but I1. Okay. Now, see, when you have a dependent sources, first what you do is that first you write this, what is this dependent variables, okay, in terms of the mesh currents in case of mesh analysis, or in terms of node voltages in case of node analysis. Okay, that we'll see it in the next. Okay. Now here, since you are solving it using the mesh analysis, we need to write the dependent variable value in terms of mesh currents. Okay. So Ix is what? I1 minus I2. Iy is nothing but I1. Okay. Now, after this, you apply the KVL equation. Okay, you forget about what are these dependent variables are there. You write as usual the KVL equation for the two meshes. Then later you can substitute. Forget about this Iy, Ix, whatever is given. Okay, without considering that, let us write the KVL equation. Once you write the KVL equation, then you will have the variables Ix and Iy, right? For Ix and Iy, you know what are the values of Ix and Iy in terms of the mesh currents. That you substitute. Okay, so here you see this is the uh, circuit what we have considered. Okay, now let us see, this is the circuit. This current is I1, I2. Okay, you know that Iy is I1, Ix is I1 minus I2. Now we'll write the KVL equation, that is plus to minus, that is minus 5, plus to minus 5 into I1, plus to minus 2 into Ix. Don't substitute at the beginning itself, you may get confused. Okay, Ix you substitute it later. Now what is this? This is a voltage source. Whatever may be the value, this is a voltage source, right? So plus to minus, what is the value of the voltage source? It is nothing but 2Ix. So you write it as minus 2Ix minus 4 into I1. Minus 4 into I1 minus 1 into I1 minus I2. Minus 1 into I1 minus I2 minus to plus 2 Iy equal to 0. Okay, right. Minus 5 I1 minus 2 Ix minus 4 I1 minus 1 into I1 minus I2. Okay, minus to plus 2 Iy is equal to 0. Okay, now for Ix, you know what is the value. Ix is nothing but I1 minus I2. That you substitute. For Ix, you substitute as I1 minus I2. Then simplify. So that you will get the equation as minus 10I1 plus 3I2 equal to 5. Do it. Do the substitution. Okay. Now, similarly, you write the for the second mesh. Okay, it is plus to minus. Okay, minus 2 iy minus 1 into, okay, minus 1 into I2 minus I1 minus 2 I2 plus to minus minus 10 equal to 0. Okay, plus to minus minus 2 iy minus 1 into I2 minus I1 minus 2 I2 minus 10 equal to 0. Now you substitute for Iy. Iy is nothing but what? I1. Okay, Iy is nothing but I1. 2 into I1 plus I2 minus I1 minus 2 I2 equal to 10. Okay, so that we will get this equation minus I1. Okay, this is the fourth equation. Any confusion? So what is the answer you are getting? I1 as minus 1.364 and I2 as minus 2.878. And Iy is nothing but I1, so it is minus 1.364 amps. Ix is nothing but I1 minus I2, so it is 1.514 amps. Did you get these answers? Did you get the answers? Is any doubts? Is any doubts? Yeah, first equation you see, first equation is, say it is plus to minus. Okay, here the polarity you see, plus to minus, minus 5, plus to minus, minus 5 I1, plus to minus, minus 2 Ix, minus 4 I1, minus 1 into I1 minus I2, minus 2 plus 2 Iy equal to 0. Okay. For Ix, you substitute it with I1 minus I2 because Ix is the current. In terms of mesh current, it is I1 minus I2. Okay. Simplify it. The first equation is minus 10 I1 plus 3 I2 equal to 5. The second equation is, you see, plus to minus, minus 2 Iy minus I2 minus I1, that is minus 1 into I2 minus I1 minus 2 I2 plus to minus minus 10 equal to 0. Okay. For Iy, you substitute it as I1 because Iy is equal to I1. Okay. Yeah, okay. Let us consider the next problem. Take down the next problem and try to solve it. Find the mesh currents in the network sheet. Here you have voltage dependent voltage source. Voltage dependent voltage sources. Here you have two voltage dependent voltage sources. Right. Now, this voltage source is dependent on this V2. Okay. See here, the mesh current, this is I1, this is I2. The equation, you should have two equations in terms of only I1 and I2 so that you can solve this. The remaining variable what you will get while writing the equation, that you need to substitute in terms of I1 and I2. Okay, so first what you need to do is that when you have a dependent sources, you need to find out what are the values of dependent variable. Okay, so these are what the dependent variables V2 and V1. Okay, what are these variable values that you need to first find out? Then you write, forget about those values. Then you write the apply the KVL as usual. Okay. Then wherever the variables are other than I1 and I2, for that variable you substitute it in terms of I1 and I2. So now let us first find out, we have two variables here other than I1 and I2. We need to find out what is V1 and what is V2 in terms of these two variables. We need to find out in terms of I1 and I2 because I1 and I2 are the mesh currents. So we should have only these two variables in the equation so that we can solve those. Right. So first we'll find out what is V1 and V2. Okay. So what is V1 here? What is V1? V1 is the voltage across this 5 ohm. See here, V1 is the voltage across this 5 ohm resistor, okay, through which the mesh current I1 is flowing. See, this is the mesh current, okay. See here, this is 5 ohm V1. Through this mesh current I1 is flowing. What they have given, V1 is nothing but the voltage across this 5 ohm. Okay. So V1 is nothing but 5 into current flowing through that. Suppose if I had the polarities like this. Okay. This is the polarity with which I am going to measure the voltage across this 5 ohm, and I have a current which is flowing in the same direction as that of this polarity. Then I can write this voltage V1 is nothing but 5I1, because I am connecting the voltage source here with positive terminal here, negative terminal here, and I have a current. Current is also flowing in this same direction, right? This is at higher potential, this is at lower potential. Okay, this is the assumed direction of connection. Now, here you can see that the current is flowing like this, I1. This is the assumed direction of current. It should flow from higher potential to lower potential. But how high they are going to measure the voltage with positive terminal here, negative terminal here. So what is the value of V1? Can you tell me? What is the value of V1? Can anybody tell me what is the value of V1? Minus 5I1. So did you get it? Why it is minus 5I1? Okay, so V1 is nothing but minus 5I1. Suppose if this was the polarity given in the problem, then it is plus 5I1. Okay, now see V2. What is V2? V2 is the voltage across 2 ohm, through which the current I2, see, you can write it separately and you can determine what is this. If you are getting confused like this, you can write it separately, this, or else directly you can write V1 equal to minus 5I1, V2 equal to what? V2, what is V2? Here you see, this is the polarity, what they have given there. Okay, the current is also flowing in the same orientation, that is plus to minus. I2 orientation, what we have assumed is also in the same direction. So V2 is nothing but 2 into I2. See, voltage is always what? It is current into resistance. Don't write it as V2 is equal to simply 2 or V2 equal to I2, like that you don't write. It should be a product of resistance into current, right? So any confusion in finding those V1 and V2 values? Any confusion? Okay. So V1 is minus 5I1, V2 is 2I2. Okay. Now let us apply equation to mesh 1. Okay, what is the equation? Plus to minus, minus 5I1. See, don't write it as plus to minus minus. You forget about these variables. Okay. You apply KVL to this mesh with the variables V1, V2. Okay, don't consider whatever the control variable they have given here. Okay. So plus to minus, minus 5 minus 5 into I1 plus to minus, minus 2V2 minus 4 into I1 minus 1 into I1 minus I2 minus to plus 2v1 is equal to 0. Okay. Now you have in this equation along with I1 and I2 you have two more variables, that is nothing but v1 and v2. For v1 you know it is minus 5i1, v2 is 2i2. You substitute those so that you will get the equation only in terms of I1 and I2. So after substitution, you will get the equation as 20i1 plus 3i2 equal to minus 5. Equation is minus 5 minus 5i1 minus 2v2 minus 4 into I1 minus 1 into I1 minus I2 minus 2 plus 2v1 is equal to 0. So when you substitute for v1 and v2, you will get the equation as 20i1 plus 3i2 equal to minus 5. Similarly, write the second equation. See, what about the second equation? It is minus 2v1 because plus to minus 2v1 minus 1 into I2 minus I1 minus 2 into I2 minus 10 equal to 0. Minus 2v1 minus 1 into I2 minus I1 minus 2i2 minus 10 equal to 0. Substitute for v1 as minus 5i1 and for the equation you will get it as 11i1 minus 3i2 equal to 10. 11i1 minus 3i2 equal to 10. Solve for I1 and I2. Solve for I1 and I2. For I1 value, you will get it as 0.161 amps and I2 equal to minus 2742 amps. I2 equal to minus 2742 amps. Did you get these values? Did you get the values? Okay. Is any confusion? Any confusion? See, always you need to check the equation whatever you have written twice because you will make mistakes in the signs. Okay. So cross verify your equation before solving it. Sometimes you will leave one of the components there. Okay. So Before solving this, we verify the equations. So the first equation is 20I1 plus 3I2 equal to minus 5 and 11I1 minus 3I2 equal to 10. That is the second equation. Is any doubts? Is any doubts?